Hello everyone. So today I'm going to explain you about pool boiling. In pool boiling we have two words, pool and boiling. What is boiling? Boiling is a process or it is a convective heat transfer process that involves change of state. That is, in boiling, change of state takes place. How? From liquid to vapor. In this process, the heat transfer process in which the liquid form change to vapor form. So this is boiling. Boiling is a convective heat transfer process that involves a change from liquid to vapor state. There are many types of boiling, such as we have saturated boiling, pool boiling, forced convection boiling, and subcooled boiling. In this topic today I'm going to discuss about pool boiling. Before discussing pool boiling, I'm plotting a graph or a curve between rate of heat transfer and the temperature so that this topic can be explained better. For the curve, taking on this axis is the temperature, and on this y-axis the Q, or we call it rate of heat transfer, that is Q. Now the curve begins in such a manner. It reaches to some top value, then decreases, then again increases and constant. So this is the curve. This curve has several parts. This is 0 degree. At this peak point or the maximum point of the graph we have, this is 30 degree temperature. Nearly somewhere here we have, this point is 5 degree temperature. In between of these two, nearly we have 10 degree temperature. After that, this temperature is 120 degrees and so on. This is somewhere say 1000 degree, and the temperature continues. This is the rate of heat transfer axis and this is the temperature axis. In this curve we have several regions. This 0 to 5 degree is the first region. This 5 to 30 degree is the second region. This 30 to 120 degree is the third region, and this 120 to 1000 is the fourth region. So what are these four regions? This first region is called the bubble convection region. The second region is called nucleate boiling region. The third region is called transition boiling region, and the fourth region is called the film boiling region. Also, in this 5 to 30 degree, that is in region 2, we have two subdivisions, that is this portion and this portion. Between 5 to 10 and 10 to 30, this 5 to 10 region is bubble dissociate region, and this 10 degree to 30 degree region is the bubble to the surface region. Okay, So this is the curve or the boiling curve, and it is plotted on rate of heat transfer axis and the temperature axis. This curve explains the pool boiling phenomena. How this curve explain? Suppose in the pool boiling explanation, suppose this is some container in which we fill water. This is the water here, and we are submerging a rod, heating rod inside this, which is connected to some electric source. This heating rod is submerged in this container which is having liquid water. So how this phenomena begins, or how pool boiling is explained, is this temperature region 0 degree, 5 degree is the temperature beyond the saturation temperature. So this 0 degree, 5 degree and all these temperatures are added to the saturation temperature of the material we are taking. So what happens? Pool boiling is a process under which a heating rod is submerged inside a liquid. That is, we submerged a heating rod inside a liquid. If the temperature of the rod is greater than saturation temperature of the liquid, that is, this is the liquid, and if the temperature of this rod reaches higher than the saturation temperature. What is this saturation temperature? In this saturation temperature, the phase change phenomena occurs of the liquid. That is, the beginning of phase change phenomena occurs only after the saturation temperature of this liquid. So if the temperature of this rod reaches beyond the or goes beyond the saturation temperature of this liquid, suppose we have some saturation temperature of this liquid, and after that temperature we reached from 0 to 5 degree, or this rod temperature exceed from 0 to 5 degree of the saturation temperature of this liquid, then that region of the curve, in that region the curve is called bubble convection region. And what happens in this bubble convection region? In this bubble convection region, the heat transfer from the heating rod to the liquid means the heat transfer process takes place in this bubble convection region from the rod to the liquid by the movement of, or by the velocity that we have, or the movement of liquid molecules which are surrounding this rod. What happens when this rod is heated, and when the temperature of this rod reaches 0 to 5 degree more of this saturation temperature of this liquid, then the molecules of the liquid gain velocity, or the molecules which are surrounding this rod get velocity or get movement. And due to this movement of the molecules, it is observed that the temperature difference between the heating rod and the liquid is generally 0 to 5 degree, and the movement of molecules result in the transfer of heat. So it is the starting in this bubble convection stage, that is in this first stage from 0 to 5 degree temperature, the starting of heat transfer takes place, and this heat transfer takes place due to the movement of molecules which are surrounding this rod, due to the velocity of the molecules which they have. So in this bubble convection region, the starting of heat transfer takes place by the movement of molecules around this heating rod, and the curve reaches to some point, say this is a point A. After that we have the region nucleate boiling region from 5 degree to 30 degree. Now since we are constantly supplying the energy to this rod, so this rod keep on increasing its temperature. Now when the temperature of this rod increases to 5 to 30 degrees beyond this saturation temperature of the liquid, then the heating coil, we observe that very small bubble formation takes place on the surface of the heating coil. This is the suppose this is the heating coil. Now what happens when the temperature ranges from 10 to 30 degree beyond the saturation temperature, means saturation temperature SAT, saturation temperature plus 10 to 30 degree of the additional temperature, then this region is nucleate boiling region is obtained, and in this region small bubbles formation takes place on the surface of the rod, and these small bubble formation takes place and get collapsed there only, means these bubbles formed and get collapsed on the surface itself. They did not have enough energy. Why this word nucleate is used? Nucleate is a word which signifies or which tells that though the bubbles are forming, because in this pool boiling process whole of the boiling or maximum of the heating is done due to the formation of bubbles when they move inside this liquid, but these bubbles which are formed in the beginning or the first formation of bubbles takes place, these does not have enough power so that they themselves can transfer all of the energy. So in nucleate boiling region, these bubbles which are forming on the surface of the rod, they collapse and get break in on the surface of the rod itself. In this phenomena continues from 5 to 30 degrees, and in this region, this part in which the bubbles form and collapse, it takes place from 5 to 10 degree temperature, and this region is that's why called bubble dissociation region. That is, bubbles are forming on the rod and they are collapsing there itself. But if we further increase the temperature from 5 to 10 degree, what is observed that these bubbles keep on adding energy, or this rod keep on providing more and more energy in the form of we have already connected this to the electricity source. So these bubbles keep on fetching energy, and we observe that bubbles start moving up to the upper surface of the liquid and get collapsed there. Earlier when the region was 5 to 10 degree, that means half of the second portion, then the bubbles collapse on the surface itself. But now when the temperature is further increased from 10 degree to 30 degree, now these bubbles from the surface of the rod reaches to the top of the top surface of the liquid and collapse there. So now they are taking the energy, loads of energy with them, and moving this energy in whole of the liquid, because from everywhere the bubbles will come and try to go to the surface, and it will spread all the energy in the whole of the liquid, and these bubbles get collapsed on the surface, and the movement of the bubbles up to the surface gradually increase in this region, and the maximum rate of heat transfer takes place when the temperature is nearly 30 degree. And this point where the maximum rate of heat transfer takes place, because bubbles carry large amount of energy and they go up to the surface, so maximum rate of heat transfer takes place at point C, and this point C is called critical point. So at the critical point, maximum rate of heat transfer takes place, and in this region the formation of bubbles takes place on the surface of the rod, and in the first 5 to 10 degree temperature range they collapse there itself, and in the second 10 to 30 degree temperature range they reach to the surface and collapse there, and thus transfer the heat from the rod to the whole of the water, and thus rate of heat transfer increases in this region. After that we have the transition boiling region, that is the third region in which the temperature is from 30 to 120 degree. Also earlier what we have seen is that the rate of heat transfer is more when the heat transfer takes place in the form of bubbles, that is in drop wise, that is the rate of heat transfer is maximum, or it is 10 times more when the transfer takes place in the form of bubbles than the film. also in transition boiling region, what we have, as the temperature of the heating rod increases continuously, we observe that the movement of bubbles from the heating coil surface to the upper surface of the liquid layer decreases. Why it decreases? Because it decreases because as the temperature rises, more and more number of bubbles are forming on the rod, and these bubbles starts to move out and try to reach to the outer surface. Now there are large quantity, or the amount of bubbles which try to reach to the surface are more, and still temperature keeps on increasing of this rod. So more and more bubbles are coming out, and the density of bubbles, or the number of bubbles, are too much or very large in number. So this, the difficulty is faced to the bubble in reaching to the top. So due to the large number of bubbles, these bubbles collapse there itself, and due to this collapse, the bubble form a layer on this rod. What happens? Bubble collapse on the surface of heating coil and form a film of the vapor on the surface. By increasing the temperature of rod, the thickness of vapor film gradually increases. What happens when this bubble collapse there itself? It is unable to go to the surface due to large number of bubbles. It collapse there itself and form thick layer, or it form layer on the heating rod itself, and this formation of layer increases as the temperature keeps on increases. And we have already known fact that the rate of heat transfer is more in the form of bubbles, or in the form of drop, than in the form of film layer. That is, when the layer has formed on the rod surface, then the rate of heat transfer decreases. Why it decreases? Because in conduction mode, as the temperature increases, the rate of heat transfer in case of vapor medium is very low. That very low condition happens due to the large thermal resistance or large conductive resistance of the vapor thickness film which is formed. That is, if this is the rod, and as the thick rod is formed on this rod, thick layer of vapor is formed on this rod, so now the rate of heat transfer decreases, as the rate of heat transfer in the conduction medium is less as it was in the bubble case, due to the thermal resistance faced by the transfer of faced in this case when the film is formed, and the rate of heat transfer decreases due to the formation of thick layer and thermal resistance, or the conductive resistance. Now this boiling is known as transition boiling, because in this region, or in this boiling region, what we have, the number of bubbles, the density of the bubbles, or the number of bubbles keep on decreasing, and the formation of film on the heating rod starts to increase. So the bubbles decrease and film increase. So transition of bubble into film takes place. That is why this region is called transition boiling region, in which the bubbles get converted into the film form, and bubbles have 10 times more capacity to transfer. The rate of heat transfer capacity is 10 times more than the film transfer, due to the resistance, or the thermal resistance, or the conductive resistance. That is why this curve now tends to come downward, because of the thermal resistance, or because the film has formed. So the rate of heat transfer now decreases, and it decreases in this region. Now this region is transition boiling region, because the magnitude of bubbles decrease, whereas the magnitude of vapor film respectively increase on the surface of the rod. Now in the final stage, or in the fourth region, as the temperature of the rod keep on increasing, what we have, the film boiling region starts. What happen in this film boiling? This film boiling region is also called radiation boiling region. What happens in this radiation boiling region? If the temperature of the heating rod is above 120 degree of the saturation temperature, that is the saturation temperature plus 120 degree, if the temperature is more than this, then heating rod starts to glow. That is why what we see when we heat up water in a bucket in the winters, then the roads starts to glow, that is it changes its color. So this is the fourth process or fourth part of this pool boiling process, in which the heating rod starts to glow, that is rod radiate heat uniformly to all the liquid and vapor molecules, so the rate of heat transfer increases with the temperature of heating rod. What happens in this film boiling or radiation boiling region? Now as the rate of heat transfer was decreasing in transition boiling region, now the rod, when it reaches above 120 degree temperature, then the rod starts to glow, and now the rate of heat transfer is in the form of radiations, and radiations transfer the heat all around this liquid, and it heats up this liquid, and the glow or the change of color of this rod leads to the radiations which boil whole of the liquid which is present inside this container. So this whole process of boiling of the liquid inside the container is pool boiling. In this pool boiling method, we insert or we submerged a rod inside the liquid, and due to the movement of molecules or movement of bubbles or the formation of film layer or due to the radiations, in the end this whole water gets boiled up, and this whole process is pool boiling process. So in this process we obtained a curve between the rate of heat transfer and the temperature, where rate of heat transfer in the initial was less, but it increases as the temperature increases. Again it reaches to the maximum critical point, then it decreases, and again it starts to increase and then become constant due to the constant radiation beams or constant radiation heat transfer. So this is a general discussion about pool boiling process. Thank you.